Oh, good day, and thank you for watching my Sci4. My name is Tom McGrath, and I'm going to be presenting to you today on the Computer Vision Algorithm Collection. This is my review of the software and some of the algorithms that go into it, CVAC for short. This slide talks about what is CVAC, and you see there on the right-hand side where there is a link to the GitHub.com location for the software that you can download and really have some fun with. The software is actually developed by Professor Matthias Kulch and his team at Naval Postgraduate School. Most of their work with this software has been for the military or for military uses, things like that, working with groups like DARPA, science engineering boards and the like, who can use this for military purposes. My goal in looking at this software is to see if it could be used in other areas, namely possibly with the Homeland Security Victim Exploitation Center. Some of the main goals for it is basically to make it easier for those people who don't necessarily have a lot of experience in working with computer vision or heavy into the math of the graphics and the metadata. They just want to be able to get in and go, okay, I have a group of photos, group of images that I'd like to use an algorithm or method by which I can look at all these pictures and all these images and possibly use that algorithm to train up that algorithm, and then go ahead and use that algorithm to actually test to see if I can label and categorize these test images, and kind of teach the computer basically how to identify certain things. Now obviously there's different algorithms out there that can do or are more specialized at looking at certain things or features in images. A lot of CVAC is Python based, and with that said, it can be cross-platform, used Linux. I did most of my work on a Windows 7 64-bit platform, and also this last point, it utilizes open source software, so you don't have to worry about a lot of licensing issues. But the one caution is any images that you use, you have to make sure either that you have a license to use them or they are in the public domain. That's a real key piece of item, especially when you're talking about any type of pictures of people who would be considered as minors. They obviously have to have given permission for anybody to use that picture. The beautiful terminology page. I'm not going to go terribly deep into this, but I had to learn some of it in order to understand what computer vision was all about. The biggest one of all, obviously, is that what is an algorithm? It's a fancy word. Basically, it's how are we going to process this function, whether it be a detection function or a testing function. How are we going to look at whether that be mathematically, process-wise, etc. How are we going to look at this image? And there's a lot of people out there much smarter than I who have developed these algorithms and who can definitely, if you want to go into some deeper discussion and or research, you can spend a lot of time on algorithms. Moving on, we talk about corpuses. Corpus, basically that's all the data about a set of images, whether you want to call that the labels, the categories, the features, etc. To include also videos. And videos, you hear a lot of people say, it's just a lot of images attached together. So now the next thing I'd like to talk about is the detector. The detector is that part of the process that finds regions or features in an image where objects might exist. Now, we'll go on a little bit further in the presentation, talk about kind of some of the different detectors that exist out there. Now, another thing is ground truth. This is when you're trying to train a detector to say, okay, this is what a face looks like, this is what a car looks like, a license plate, whatever. You want to have known good data, i.e., I want a picture of a license plate, I want a picture of a face, etc., somebody walking. And once you know you have good good training evidence for that, then you can go ahead with the knowledge that I'm using good data, I'm starting out with it. That way, when I go to test it or find out if my ground truth data has trained up my detector well, will it in fact test out against other known good objects. And then those last 2 points are kind of hand in glove, if you will. Training is exactly what it sounds like. You're training your detector to find or to tell it this is a face, this is a hand, this is a glove, etc. You want to be able to have it say, okay, I understand that the label and or category associated with that object or feature is this. Testing is where you actually give it an image and say, okay, based on the categorization, based on how you've put the training category through its paces, can the detector in fact look at an image and tell you if it does or does not have a that specific image or feature in it. Now, one might want to look at like I've talked about before, the process. That you have features in all the images that we look at. It's like, okay, what are they going to look for? Well, there's 3 things that most of the detectors look at right now. They have either edges, is there a sharp drop off, a 0 to 1 type, dark to light, corners, but most of what many of the specific detectors look at of recent years are interest points or regions of interest, where you can, based on the mathematical orientation of these regions, how they graph out, get into much deeper math there, but basically those form those orientations, whether they're adjacent or distant, the spatial orientation, etc. That type of stuff actually forms identification and or words, and we'll get into some of those algorithms. For example, one is actually called bag of words, which used to be, a few years back, used to be called bag of features. And that's just kind of an interesting name for, okay, here are all the features that are associated with a person, a face, a car, you name it, all the mathematical features that make up that object will actually, can be used to categorize or label that image in the future. And then the next one, with the algorithm looking at the detected features, I note there that it says this is where most of the processing time is consumed. That's absolutely right, because you look at a training, when a image or detector gets trained, it's usually fairly quick. It knows that there's labels there. It's more of kind of like a quick memorization. Okay, I understand, I've got it. Now let me look at the new ones. And then it basically says, okay, I'm going to look at this new image, see what it's all about, see if it matches any of these features, and then based on it mathematically in the algorithm or in the process, make a determination to classify it as a yes, that's one of these objects I'm looking for, or no, it's not. And these are a couple of the algorithms that I spoke of earlier. Bag of words, again, is one of them. Another one that's out there or within the CVAC, in addition to a deformable objects algorithm, is called the Viola-Jones Object Detection Framework. Again, a lot of words, a lot of math, but the easy way to talk about it is it's extremely quick object detection framework that can process some of these images almost in real time and identifying certain features or objects. And one of the biggest ways it does that is it looks again at those specific interest points or regions of interest points and just only goes after those things. It doesn't scan the entire picture and go pixel by pixel. That's how it picks up some of its speed, in addition to another item they call ADA Boost, which is another software kind of adder feature that just speeds up the processing. And as I say there's many other algorithms. The CVAC collection only deals with a few because it's just kind of coming out now, but it's more, again, like I said, to give the user interaction with these algorithms instead of having to know all the math, the graphics, pixels, all the stuff behind it. Anyway, let's move on. A little bit about the operating environment. Was running on a Windows 7 64-bit platform. These are a lot of the must-haves. In order for it to work correctly, you have to have Python 2.6. Some of the mistakes I made, I was running a 64-bit at first and had to switch to a 32-bit because I was getting a lot of errors. Of course, the CVAC binary. And then there's some other files that I'll get into when we look at the demonstration. The Python imaging library, or the PIL, and the MATLAB runtime software, or what they call MCR. That'll be more important for some of the other algorithms. And then the compression library, zlib. And we'll continue on with the demonstration portion of the software. I'd like to take you through kind of where the software will get installed, some of the required files that go along with it, and then show you some of the detection programs that run, as well as some of the training and other algorithms or scripts that run and actually work with data at remote locations, or remote corpses, if you will. So let's move on. Okay, first I'd like to go ahead and just show you some of the files that'll be in the CVAC directory or wherever you choose to install it. A lot of the third-party software that is working with it is actually the ICE, the image compression. Also, you have the OpenCV or Open Computer Vision. That's the open source software. And some of your key programs that run with the system. One thing I did neglect to indicate as part of the software that runs with this whole installation is Java. So your Java runtime software needs to be at least up to a 1.6. I've been running it with a 1.7 without any issues. And then a couple other files, mainly the start services.bat file. When you install the software, this will need to be configured, and we'll take a look at that right now. So the start services.bat, three things that absolutely must be configured when you set this file up and start it. It's your file, batch file that needs to be running while you're actually doing the detecting or training on the scripts. One's the installation. Where is this program actually installed? Two would be your Java executable. Again, I said I was running Java Runtime Environment 7. And then your Python location and specifically the executable script for that. Everything else in this batch file plays off of those variables as far as Java and Python to launch the CVAC services. And since we're here, I'm going to go ahead and talk about the run.bat file. This is simply a way to set up the Python path before you execute every single script, so it knows immediately. It doesn't have to ask. You tell it immediately which paths you want included in basically in your library to the Python scripts, additional ones that you'll need, and then the third-party ICE Python scripts that you'll need as well. And then to also point the algorithms and scripts at where am I going to find the DLL for the MATLAB compiler runtime, the MCR. And then this last part is just launch Python with whatever first argument you throw in there. That's basically your script that you want to run. Key thing with executing any of these scripts is that you're running them from the installation directory at the root level. Not root permission necessarily, but the root level of the installation directory. Now let's go ahead and take a look at one script, this one being the prerequisites Python script, which in the tutorial for this software you'll note that as soon as you run it, it basically checks to see if all your services are running. And in this case, it's looking at the ICE, CVAC, if your paths are all correct, and EASY, which is the module that Professor Kelsh and his team developed that interacts with, whether it be the open computer vision functions or any of the other image evaluation functions that they use. Another one of the scripts that we want to run that I would like to demonstrate for you is the training script. Now, just to point out where all these scripts are that I'm pulling up, if you go into the demo directory, we ran, the first one was the script prerequisites, sorry about that, prerequisite script. And this next one that I'd like to run for you would be the training Python script. And one thing to note, again, the first thing I did before I started running any of these scripts was I ran under the bin directory start services.bat. That's what actually generated the two CVAC services windows, the C++ and the Java service windows, which actually show you what's happening while the script is actually processing out. So we'll go ahead and run the training script now, and I will kind of talk through a little bit about what's happening while it is executing. So at this point, you're seeing the training take place, extracting the features from the training images. In this case, they're Canadian, Korean, and US flags. Again, one of the key ideas here, or key pieces to note, is that the number of descriptors that it comes up with in describing these features, that number, depending on its size, can have a huge impact on how long it takes to identify certain pictures. So what the results have generated here are various pictures that fall into that have been identified through the running of the testing function. And basically these are the let's see here, various images that came up. It says cars1.jpg, cars2, cars3, corporate logos, an Italian flag, Canadian flag, and a Korean flag, and US. And basically all these pictures have been generated up to pop up on your screen. There's corporate logos, and that's basically what that script will do. And we see one other script here. This last script that I'd like to demonstrate for you is called the Label Me script, or Label Me cars. Basically what it does, as you launch it, label me _corpus.py, it's going to actually reach out to the server up at MIT where the Label Me system is running. And again, I'll show you some of those images in a second that actually come up. But what this was actually doing was querying a directory of about 100 images for labels such as car, wheel, camera, license, and it matched 21. Actually, maybe it was 21 out of 21 for specific items in those categories. And all this was being done through Java and through the MATLAB MCR DLL. As you can see, there's a number of images that they came up with. But what's more interesting is as it was running, it was telling you which images that it was pulling down, and also how many artifacts that it was finding. And then it also, as part of that script, it actually pushes the images to your desktop so you can actually look. And this is what a basically labeled image within the Label Me directory at MIT looks like, whereas a user such as yourself would take an image, upload it, and then circle, okay, that's wheel, rim, this whole thing might be car or truck. Move on to some other images that came up. Car door, again, wheel, rim, license plate. The more specific you can get to a vehicle in circling certain items, the better. Back window maybe. Again, van. It's always good to have different viewpoints on certain images. That was the back. Last image was right side of the vehicle. These are all left side except for the SUV. And then wheel, rim, again, license plate, wheel, rim. In Label Me, you have the capability of zooming in and being a little bit more fine with your tracing. But what this basically shows you is that you can search through the Label Me architecture, get the images that are labeled, but you can also push this type of script up against a detector and train images, or train a detector to say that is a license plate, that is a back tire, that is a side mirror, etc. It all depends on how deep you go with labeling and selecting, and how good your pictures are as well. But this actually generated, it popped up the 21 images that are in the Label Me directory up at MIT. And there are other, depending on property files, other locations you can go to, as far as Caltech, Stanford, you name it. There are tons of data sets out there, but as with anything, it's buyer beware. Make sure what you're using is actually ground truth. And so that is it for the demonstration side of the software. And just a few things to wrap up here. Some of the challenges, tips that came up during the time that we were researching and design and setting up this software. The run.bat file became crucial as far as running the scripts to make sure your Python path was set. An absolute requirement there. Again, running the program from the root of the CVAC installation, just from the design of the way the scripts were written and the services .bat file was configured. This was also important for all the scripts and references to work correctly. The prerequisites.python script there it gives you, it's kind of the warm and fuzzy check. Is everything operating properly before I start launching into some of these other scripts? And one of the key things, since a lot of the work I do on a normal day-to-day basis is done on a government network, trying to run some of these scripts that reach out to remote ports on different systems could very well be blocked just for security purposes. So running this at a home station may be your best bet. And again, some of the references, absolutely out to this PDF at the Moves Institute that Professor Kelsch is part of. Great document to get familiar with the software quickly. The Label Me information, that is a great one. You can get your own account. I've had mine account there ever starting this project. Great to develop and see what other people are working with out there as far as images and how they're labeling them. Dr. Zaliski's reference on computer vision, if you really want to get into the deep nuts and bolts of how does this stuff work, why does it work well, does it not, he's one of the best people out there writing on it today, and he's taught up at Stanford, University of Washington, worked for Microsoft for quite a while. And again, a little bit more about some of the image databases out there. And if you want to get into a little bit about what some of the third-party softwares are that are actually supporting the whole CVAC setup, talk about the internet communications, that's basically what's doing the heavy lifting behind the scenes to connect up to MIT, Caltech, or whatever corpus or data set you're trying to work with. That's what makes it happen, and getting the data and information back to you. And one thought I'll leave you with is you might want to think about, do we need more training data as far as training the detectors? We've got tons of images now. Why not use more? And a great great document paper that I recently read on more training data versus better models is worth a read before I guess one would launch down the path of more is better. And that concludes my presentation. I appreciate you listening, and I wish you a good day.